Big hello to the viewers. This is Hanil Patel, and I'm talking about this video is going to be a part of a submission for Trimble Hackathon 2019, and the project that I worked on is called Predictive Maintenance. And let me just give you a brief introduction. I'm Hanil Patel. I'm an integration analyst at Trimble Maps. We are located in Princeton, New Jersey. So let's get started. So imagine if you will be able to predict truck failures or any sort of vehicle failures before they happen, right? So that's where the idea of machine learning and that's where the idea of preventative maintenance comes in. Machines are so efficient at understanding relationship between data, as compared to humans. We cannot look at, giant Excel sheet and we'll be able to figure out the connection. Machines are really good at doing that. So, what are the maintenance strategy that we have in place in this world right now? So we have broken and repair strategy, right? I come from a trucking logistics supply chain industry. If you're waiting for your trucks to break down the middle of the freeway to repair it, it's already too late. There's so many things that could go wrong. So what does trucking industry do nowadays? They do preventative maintenance. Preventative maintenance is very wasteful. If you are changing your tires before they are worn off, if you're changing your tires based on the mileage they drove, that's very wasteful. Yeah, the same goes with our consumer sector. Consumer sector meaning our cars and things like that. Every 5,000 miles, so you have to bring your car in. You have to wait for 2 hours for them to check all those things and do the preventative maintenance on that. It's so wasteful. Predictive maintenance is so good. We already have. So why should Trimble be doing this, right? So Trimble already have access to ELD data from the trucks. We already have access to. So trucks acts as a giant IoT devices for us, giving us access to all the data. So we already have tire pressure data, sensor data, and all those data. All we need to do is deploy the machine learning model based on that will be able to tell us that machine something could go wrong in next 200 days or not, right? So predicting maintenance could help our users have higher uptime and reduce the preventive maintenance costs, and we'll be ready for a self-driving future moving forward. So yeah, so let's based on that, let's get started with our demo. So yeah, let me just briefly talk about what I've created. So I created LSTM model using a NASA Turbofan dataset in order to predict the remaining useful life of a jet propulsion engine. This concept goes similar with any sort of vehicle out there, right? If you have data, you could implement this concept anywhere. So in addition to that, I've created a dashboard and a prototype for visualization purposes because it's very important to incorporate those engineering ideas with the business aspect for our users to be able to visualize those things, right? So with that, let's get started. So yeah, um, let's take a look at this. So this is a visualization tool that I've created. User will be able to see where the trucks are at. They'll be able to click on it and see dispatch and all the other details. And they could also see. I'm sorry. Uh, yeah, they'll be able to see information about this cool visualization comes in about the trucks and things like that. And this is the best part. So now this window will open up and this window will be able to give them more details about the sensor data. So you'll be able to see your vehicle system check dashboard, trucker ID, remaining useful life. So we could just start this visualization, and this is a live visualization coming from or using from the CSV file, but this could be simulating a live environment. So this is a tire pressure, it's an engine, drive shaft data, powertrain, transmission, brake, gear, all those things. And based on that, I've created like a cool visualization here that yellow means okay, but red, if it goes into red, like you have to pay more attention to that. And the system based on this sensor data, this remaining useful life will go down, right? So now it's 68, 64, meaning that this machine could fail in 64 days. right? So this is just, which is not bad. So you could create your threshold to be 50 and things like that, and you could do that. So basically, you see your live split chart here, which will, tire pressure data coming in, and which is live. This is all live. Looks super, super cool. Okay, so yeah, let's just briefly talk about the LSTM model that I've created. Basically, this LSTM model is created using Keras. Keras allows us to do very rapid prototyping for machine learning models. And this model, this one has a sensor, 21 different sensor data from provided courtesy of NASA, and different settings and IDs and cycles and things like that. So you do the data processing. You have to create your training data set. You have to identify your testing data set. I've also created a validation data set in order to validate the efficiency and error loss and things like that. Anyway, so let's move forward. So basically, you generate the labels, and this is sort of like what data looks like. You got all your different sensors and all the information, and this is R square. This is for 50 epoch. I'm running this, and okay, let's get to visualization part. So we got the training and test, and we got the model R square data for that. So this is, it's pretty good. It's kind of understanding. It's going down over time, so which is pretty good. So based on this, my MAE is 18, and R square is 63, which is a little bit higher than what it should be. But consider this. So this data is predicted data, the blue one, and we get the green one, which is actual data. So um, my output is going to be based on the time series data. The output is going to be remaining useful life, which is going to be a double value, right? So based on that double value, the rate might be slightly different, but generally the trend seems to be pretty good, pretty well aligned with our predictive model, because it's not that, like, we don't see predicted all the way at the bottom, sorry, actual model all the way at the bottom, and there's no higher variation. There's a slight variation between actual and predicted. So this model is already performing pretty well. I haven't. So let me just briefly talk about what I'm using. So the first layer is LSTM is a 100 unit, followed by LSTM another 50 layers, and then LSTM deep learning models get overfitting over time as you go deeper, and 150 is 150 units, just already pretty large. So I created a dropout in order to make sure that there's an overfitting in the data, and the final layer, it's a dense output layer with a single unit and linear activation and regression problem. So yeah, this is data, and everything will be available on my GitHub, and I'll also post everything in Google Drive. All right, thank you so much. I hope to hear from you guys soon. And if my mic or audio is not so good, I apologize for that. All right, thank you so much. Thank you. Have a great day. Bye bye.